So a system is what we define as an object or a group of objects, and within a system those objects tend to interact with each other. And the key thing from an energy perspective is the fact that within a system energy can be stored in a variety of ways, and the way energy is stored can actually change. So we can take a look at a few examples. So the first system we're going to look at is a ball being projected upwards. So we have a ball over here, it's projected upwards and takes a new position up here. So what we can say is that if we take this point as 0, then at the beginning you throw the ball upwards and you have kinetic energy in the ball. So there's some kinetic energy. As the ball rises upwards, the speed of the ball would decrease, so the kinetic energy would decrease until you get to the point where the ball is at the top of its arc and reaches its maximum height, and at that point all of the energy is converted to what we call gravitational potential energy. And we'll look at both of those in a bit more detail later, but that's one example of an energy transfer within a system. The next example we're going to look at is if you have a moving object hitting an obstacle. So you have an object over here and you might hit this wall over here, and so you end up with, in fact we'll just draw the final position again like we did last time. Final position of our object is over here and it's moved in this direction. So once again at the beginning, because the ball is moving or the object is moving, got kinetic energy. And what happens is once the ball or the object actually hits this obstacle, the energy is dissipated. A lot of the time it's dissipated as heat and sound, and is actually often, when we say it's dissipated, it goes into internal energy within this wall here. And again, we'll talk about this in a bit more detail later on, these different types of energy. But essentially, once again, we have this energy transfer. The kinetic energy is then goes into thermal energy or sound energy or internal energy. Let's take a look at another example now. So now we have an object being accelerated by a constant force. And so if you look at the videos that we've done on force and acceleration, then this should come as no surprise to you. But when you have a force acting on an object, then we'll draw our force over here. And then what happens is the resultant force causes an acceleration. And so once again, we'll draw our ball in its final position. But the idea is it has sped up. And the idea with this is when you have a force moving through a distance, then you are also having a transfer of energy. So the energy comes from wherever this force came from. So perhaps this was chemical energy when you push this ball yourself with your hand. The chemical energy in your body was converted to kinetic energy to push this ball, and so until this ball has a store of kinetic energy at this stage. And what we can say here is that work has been done. Okay, so work has been done, i.e. energy has been transferred. That energy has been transferred to kinetic energy to cause this ball to move. And we should be familiar with the formula that work done is equal to force multiplied by distance. And if you're not too familiar with that, don't worry too much, but that is in our section we dealt with forces. But then here the main thing we can say is that you might have chemical energy at the beginning. This is from your muscles which actually push the ball. So right here, chemical energy, and that's then converted to kinetic energy in the ball. Okay, so now let's keep going. Let's look at another example which we need to be aware of, and that is a car actually slowing down. So once again, we'll draw our car out like this, and the car is initially going at a certain speed and eventually it slows down to a stop. So you could draw the car over here, and at this point it's no longer moving, so we'll just put that speed is equal to 0. So what's happened is you have kinetic energy at the beginning when the car is moving. You then hit your brakes. The brakes transfer energy as heat energy, and this is dissipated to the surroundings, and so your kinetic energy is transferred to thermal energy to cause this car to come to a stop. And finally, the last example we will look at is the example of heating water to a boil in an electric kettle. So we'll draw our kettle out. So this is our kettle, and it's going to have some kind of base over here, and this is going to be plugged into our mains electricity supply. So that is our electricity going into our kettle, and so you might have some water over here. And the idea is that over here you've got this electrical energy, and that is come from the mains electricity supply. This then travels into your kettle and heats up the water, so you end up having thermal or heat energy in your water inside the kettle now. Okay, so that's the energy transfer going on here. So that's some examples of energy transfers we need to be aware of. I'll go into a bit more detail about the types of energy in a later video. But for now, let's do a little quiz to see what you guys have remembered. Okay, quick quiz. Pause the video to have a go, and we'll go through the answers now. Question 1, describe the energy transfers when you throw a ball up from rest and catch it again. So if the ball is at rest, first of all, then it's got no kinetic energy. You throw it up. So you could say the action of throwing is a form of chemical energy from your muscles. That's the first source of energy. That it gets converted to kinetic energy when the ball starts moving. And as the ball increases in height, then some of that kinetic energy is actually transferred to energy. And once it reaches maximum height, it's all gravitational potential energy, no kinetic energy, because the ball actually reaches its maximum height and has no velocity, no speed. Then the ball starts to drop again, and so you decrease the gravitational potential energy, and it increases in kinetic energy until it hits you in your hand again, and you catch it, at which point the energy is dissipated as maybe sound energy or heat energy when it hits your hand. Question number 2, describe the energy transfer when you heat up soup on a campfire. So first of all, the campfire is the source of energy, and that source you would say is a source of chemical energy, because it's the energy from the wood or whatever fuel you've used to light that campfire. That is then converted to thermal energy to heat up the soup. Okay, so essentially the heat energy in the soup then causes the temperature of the soup to rise. Okay, so hopefully you got those correct, and I'll see you in the next video.